memory, storage, Calldata. What are these keywords about? Let's find out. The Ethereum virtual machine has three areas where it can store items. The first is storage, where all the contract state variables reside. Every contract has its own storage, and it is persistent between function calls and quite expensive to use. The second is memory. This is used to hold temporary values. It is erased between external function calls and is cheaper to use. The third is the stack, which is used to hold small local variables. It is almost free to use, but can only hold a limited amount of values. Let's take a look at some examples. So we'll be using this contract simple store. This contract has a struct item and this item array that is public. So because these variables are created inside the contract outside the function, they are automatically stored in storage. Now in this first function we are creating an item in memory that is equal to an instance of the struct item, and we are pushing that item to the items array. Now, these two functions, get using storage and get using memory, are really what we are looking for. So in the first case, get using storage, so we have this item storage item that is created and that we are assigning an item from the array, a specific item from the array of items, and this is stored in storage. We have something similar in this function get using memory. In this case, we are creating an item memory and assigning an element from the items array. Because we are assigning a storage reference data to a memory reference variable, we are copying data from the storage to memory. New memory is allocated, and that results in more gas being used. Now let's take a look at these two functions. We have the add item using storage and add item using memory. In the first case, we are creating an item storage and assigning it an element from the array, and we are trying to change that element. So this is a struct that has this uint variable, and we want to increment it with the parameter received in the function. In this case, units changes in items because this item is pointing to an element in the array that is stored using the storage. In this case, in the add item using memory function, we are creating a memory item and assigning it an element from the array. But because this is an independent copy, we are not changing the item inside the items array. We can change data allocation only for parameters of functions, local variables and functions. Whenever a storage reference is casted to memory, a copy is made, and further modification on the object does not propagate back to the contract state. So this was what happened in the add item using memory function. Memory reference can only be assigned to storage reference if memory data can be copied to a pre-allocated state variable. It's important to notice that assignments between storage and memory always create an independent copy. Assignments from memory to memory only create references. This means that changes to one memory variable are also visible in all other memory variables that refer to the same data. Assignments from storage to a local storage variable also only assign a reference. All other assignments to storage always copy. Examples for this are assignments to state variables or to members of flow variables of storage struct type, even if the local variable itself is just a reference. Now let's see another example. We have this contract storage vs memory. Inside this contract we have this array of uint called x. The data location of x is storage. This is the only place where the data location can be omitted. So we have a function f that receives this memory array that is an array of uint. Inside we have this function receiving the memory array. This works, it copies the whole array to storage. Below we have a new storage array of uint called y and is being assigned x. This works, it assigns a pointer. This y7 works fine and it returns the 8th element of x or y. In this case, if we pop the last element of the array, it works, modifies x through y because y is pointing to x. If we delete x, it will also work and also modifies y by the same reason. Y is pointing to x. Now let's try this. As you can see, the first one doesn't work. When we try to assign the memory array to y, it says that memory is not implicitly convertible, and this would need a temporary array in storage, so it doesn't work. In this case, it can't delete the pointer. This does not work since it would reset the pointer. What do you think it happens when we call g function and pass x? It will call g handling of a reference to x, and because the receiving parameter is defined as storage, in the second case what will happen? It will call age and create an independent and temporary copy in memory because it is using the memory keyword. Let's see another example. Now in this third case we have memory versus Calldata. So this memory test function receives a string, example string, and we are assigning a new value to that example string. And we can do this because we can modify the memory. Also, we can use memory as we have seen inside a function. So we can assign this example string to a new variable. When using Calldata, in this Calldata test. In this case, because it is Calldata, we cannot modify example string, but we can return it. So to sum it up, memory, Calldata and storage are keywords that define the data area where a variable is stored. Memory should be used when declaring variables in the function. Memory variables are stored in memory and exist while a function is being executed. Storage variables are state variables that are stored on the blockchain. And Calldata is only available for external functions and is a special data location for the function's arguments. Make sure you like and subscribe so you can be notified when I upload the next video. Thanks for watching.